Can you overcome the curse of dimensionality in reinforcement learning? Imagine trying to find your way through a maze that keeps expanding as you explore. That's what the curse of dimensionality feels like in reinforcement learning. As the number of variables in a robotic system grows, the space of possible states and actions explodes exponentially. This makes learning effective policies for robots with many joints or sensors incredibly tough. But don't worry, researchers have developed smart ways to handle this challenge. They use techniques to simplify the problem without losing important information. One popular method is dimensionality reduction, which finds lower dimensional representations of complex data. Think of it like compressing a large image into a smaller file that still shows all the important details. Robots often have many sensors and joints, but their core behavior usually happens in a smaller, simpler space. By focusing on these key features, reinforcement learning can work more efficiently. Another approach is factored models. These break down the robot's environment into smaller parts, like limbs or sensors, and learn separately. This way, the robot can plan locally and then coordinate these parts. It's like managing a team where each member handles their own task but works together. Researchers also use hybrid methods that combine model-based and model-free reinforcement learning. Model-based methods use knowledge of the robot's physics to predict what will happen next, reducing the need for endless trial and error. Model-free methods learn directly from experience. Combining both allows robots to learn faster and handle more complex tasks. Using prior knowledge about the robot's design or task helps too. For example, knowing that certain joints move independently can cut down the learning space. Regularizing policies to keep trajectories in lower dimensional spaces also helps improve stability and robustness. These strategies have already been applied to robots walking on uneven terrain, manipulating objects with multiple joints, or navigating complex environments. They show that overcoming the curse of dimensionality is possible, but it requires clever techniques that exploit the structure of the problem. While it's not entirely eliminated, reinforcement learning is becoming more capable of managing high-dimensional robotic systems. This progress opens up new possibilities for smarter, more adaptable robots in the future.